MathML, and of course the style sheet language. So who do you all use this? Well, who here knows what CSS is? Who uses CSS? Okay, pretty general understanding. Okay, right. So there's a good thing about going on is there's more exciting CSS coming, allows you to do more powerful things. So, and the neat thing together is we're pushing now to get them all working on one page. So here's an example. Yeah, you can't read it very well because this is a specific example. Interesting thing about this is it's in columns, but it's in columns not because it's that's not a table with the columns. It's in columns because it's told it's just using style to put it in columns. And as I increase the size of the font, it goes into 2 columns. And that makes it so much easier to build a website which will work on the phone. Because if now you imagine I've got this on my phone, and I shrink it up, then it'll turn into a 1-column thing. So that's just one example of something that you can do. Do you notice that it says example across here? And it does that using lettering, which has got shadow on it. That's something new. This whole article, in fact, is about an idea. See up in the top corner, a filter called Gaussian blur. Okay, who knows what Gaussian blur is? Yeah, okay, so if you're designers, you know that Gaussian blur is a technique for taking one diagram, taking something and making it fuzzy. And you can, so that's a new feature. And interestingly enough, in this article, that little diagram is an SVG diagram, and underneath it is the same diagram, but with Gaussian blur turned on. And that's how this article was written. You'll notice mathematics in there. That's not a picture. That is not that mathematics. There, I can select. I can copy and paste it. Okay, and it's actually written by using tags for each of the mathematical things. So that's a great improvement if you're trying to do something like a journal or anything scientific. Now, if I missed anything, the difficulty here is spotting all the things. Video tags, famous one. I won't rely on just using online video. Now this page is a complete mixture of HTML and SVG. Let me go through it. You can see that this thing is a video. It looks a little odd. Well, it's a funny shape. That's because it's a video inside, it's an HTML video tag inside a piece of SVG. SVG, you can squish, you can share it. So it has an SVG transform applied to it to make it that funny shape. So all these buttons are made with SVG, and you can attach JavaScript to them so that they do things. There's a piece of MathML. You can write the math. If I press this, the mathematical formula changes. That's because there's a piece of JavaScript which writes the mathematical formula. The wording. This is SVG. That's text, which is accessible to the DOM. So you can write JavaScript to do things with the text. And in fact, here's a little form. Yeah, it's the form which has got a bit squish. But now if I add things on, you can see they're getting added on also into that piece of SVG where the writing is following a line. I can make buttons. The buttons can connect to the video. So you can just connect with not very many lines of JavaScript. So the video, I can either use the controls here, or I can make my own controls and make it run. And you can put a point in the video trigger an SVG transform happening on the video. So by putting video, it's because of the modularity of this design, the fact that you can do video inside HTML, inside SVG, inside HTML, okay? You can do all kinds of things. And that's much more fun and so the message is when you're designing languages, keep them modular, make sure they work together. You can try this, these slides are on the web, they'll be, give out the URL at the end, and you can find them. Philippe Aguirre is the person who put this together. And there's only one thing I didn't mention, of course, is the Gaussian blur. So you see where it says, this is SVG at the top. If I press the Add Gaussian Blur button, we can blur some of the SVG. So everything connects. You can make a button which connects to JavaScript. The JavaScript connects to the CSS, which styles the SVG or styles the HTML, and it's all part of a consistent world. I think that's pretty neat. I don't know. With myself, I was impressed when I saw that. You have to tap all the people working in these working groups who make that thing happen. To do the slides, you have to use Firefox 3.5. They're in 3.5. I'm just using regular 3.5 off the beta. No, I'm on the beta program, but it's the regular. There's nothing special in there. Okay, so I talked about documents. That's taking documents maybe to a little bit of a slightly crazier extreme, but should be really fun for building web applications. And what's really, in a way, the more significant thing about the whole HTML5 movement, it's not just that it's making, you've got cooler web pages. Cooler web pages are important and they're a very valuable part of the web. And even static web pages will continue to be a valuable part of the web, but also it opens the door to turning your web page into a web application. An application which is as powerful as an application on your desktop. An application which can get at, when it's running on your phone, it can get at the storage, it can get at your address book, it can get at your location. I don't have a slide on the geolocation API. So the geolocation system allows you, in a script, that's working in Firefox 2, to say, hey, where am I? So that you can put up within your SVG diagram, you can put up a little spot, which is actually a web page, which is the map for where we are. So that web applications are a really big direction on the web. Okay, so if you put your documents on the web using HTML and CSS, you put your and now SVG and MathML, you put your data on the web using RDF and Sparkle. RDF is a basic data language. You can there are programs to take data out of spreadsheets or out of MySQL databases, and you can turn it into RDF, and then you can do all kinds of things with it, which are different to the things you do with normal data. But the great thing is when you take RDF data, you can put it all together, and you can consider it as one great big interconnected web of data, an interconnected graph of data. So we say nodes connected by relationships, just like that diagram I had. This document describes a system. The system unifies these systems. The semantic web is just like that, and it uses URIs to things starting with HTTP to identify each node, and also for the relationships. When you have a relationship like this describes that, the relationship itself is identified by URI as well. And you can look up these URIs and find out data about what they mean, and that data can make your program work. So that with this web of linked data, you've got all this semantic web technology which allows a computer to work out how to do stuff without people telling it so much.